In today's video, we are going to understand the concept of binary frequency shift keying. You can say this is the digital equivalent of frequency modulation. As in frequency modulation, we change the frequency of the carrier signal with respect to the instantaneous value of modulating signal. And as the modulating signal is the analog signal, you have various frequencies of carrier signal. In this case, what we are doing is we are changing the carrier signal frequency with respect to the information signal which is in the digital form or in the binary form. So that means you have only two types of variations, that is either bit 1 or bit 0. So you will be having only two frequencies, a high frequency and a low frequency. So that means carrier frequency will change into two different frequencies. One frequency is high frequency when bit 1 is there, and another frequency is a low frequency when bit 0 is there. So basically binary frequency shift keying signal is having a frequency signal which is having two different frequencies, one high frequency and one low frequency. Mathematically, if I want to explain the FSK signal, it is basically A cos omega c plus minus omega t, where plus means bit 1 and minus means bit 0. Plus means two frequencies are adding, that means the frequency is high, and minus means two frequencies are subtracting, that means the frequency is a low frequency signal, that is represented by bit 0. So this is how your BFSK signal is represented theoretically, mathematically as well as graphically. Now we will see how BFSK transmitter and receiver works. So this is the BFSK transmitter. In this, a frequency modulator is there, and which is having two input signal. One is the carrier signal, another is the bit sequence which you want to transmit, which is containing the information in the binary form or digital form. So when you combine this bit signal with this carrier signal, the output will be FSK signal. That means output will be this. Then this FSK signal is received at the receiving end. So you can say this FSK signal is fed to two different multipliers, as we have two different frequencies. One frequency is omega c plus omega and another frequency is omega c minus omega. So we have to use two synchronous multipliers. When FSK signal is given to this synchronous multiplier, this FSK signal will be multiplied with cos omega c plus omega t, and when this FSK signal is fed to this synchronous multiplier, the lower synchronous multiplier, it will be multiplied with omega c minus omega t. So after multiplication, this signal is given to this difference amplifier input 1, and this signal is given to difference amplifier input 2. The output of difference amplifier will always be input 1 minus input 2. So the difference amplifier's output is finally given to the low pass filter, and low pass filter will remove the high frequency component, and the bit sequence BT will be received at the output end. This is how your binary frequency shift keying operation is done at the transmitter and at the receiver. Now, how this FSK signal is given to this synchronous multiplier, how it will be multiplied, what will be the output of synchronous multiplier, then what is the output of difference amplifier, that we will see mathematically. So you will be understand the concept better. So now let us understand the concept mathematically. Suppose bit 1 is transmitted in FSK signal. So bit 1 is represented by A cos omega c plus omega t. It will be multiplied with omega c plus omega t frequency. So it is multiplying at synchronous multiplier 1 with cos omega c plus omega t. This will be A cos square omega c plus omega t. Then cos square theta can be written as 1 plus cos 2 theta. So it will be A by 2 1 plus cos 2 omega c plus omega t. This is the output of synchronous multiplier 1. The same FSK signal, which is A cos omega c plus omega t, is now fed to synchronous multiplier 2, which is having frequency omega c minus omega t. So now it will be A cos omega c plus omega t into cos omega c minus omega t. It will be now cos A cos B. So this will be a by 2 cos 2 omega ct plus a by 2 cos 2 omega ct. Now the output of difference amplifier, that means it will give the output as input 1 minus input 2. So input 1 is this and input 2 is this. So input 1 minus input 2. Output of low pass filter. Low pass filter, what it does, it removes the high frequency component. This frequency is twice of omega c, this is twice of omega c, this is twice of omega c plus omega t. So all these three frequency terms are high frequency component terms which will be removed by this low pass filter, and you will get the output as a by 2, which is corresponding to bit 1. So that means bit 1 is transmitted. Now let us understand the same mathematical expression for bit 0. So when bit 0 is transmitted, your FSK signal will be a cos omega c minus omega t. When it is given to the receiver's first synchronous multiplier, it will be multiplied with cos omega c plus omega t. So the output of first synchronous multiplier will be a cos omega c minus omega t into cos omega c plus omega t, which will be a by 2 cos 2 omega ct plus a by 2 cos 2 omega t. Similarly, output of synchronous multiplier 2, when this FSK signal is given to this synchronous multiplier which is having frequency omega c minus omega t, it will be multiplied with the same frequency, so it will be squared. So it will be a cos square to omega c minus omega t, which can also be written as a by 2 plus a by 2 cos 2 omega minus omega t by the trigonometric relationship. Then the output of difference amplifier. Difference amplifier will give the output which is input 1 minus input 2. Input 1 is this and input 2 is this. So this minus this. So this is the input 1 and this is the input 2. Now this whole expression will pass through the low pass filter. And this low pass filter will remove the high frequency component, which is twice omega c here, twice omega here, and twice omega c minus omega here. So these three frequency components will be removed. Only minus a by 2 will be passed through the low pass filter. So the output of difference amplifier is minus a by 2, which is corresponding to bit 0. In the previous mathematical expression, we have seen that we received the a by 2 when bit 1 is transmitted. So bit 1 is corresponding to plus a by 2 and bit 0 is corresponding to minus a by 2. This way we can receive all the bits coming from the transmitter, or we can receive all the binary data which is transmitted for the operation. So this is what the complete explanation of binary frequency shift keying. I hope you understand the concept well. Now if you have any doubt or query related to this topic or any other topic, you can write it in the comment section. Thank you.